This video is only really going to have a look at one graph, and we're looking at changing atmosphere. We often think of this atmosphere as a very fixed thing because we've only experienced really one kind of atmosphere. Slight changes in certain gases like carbon dioxide get a lot of worldwide press, but in the grand scheme of things, they've not actually been that big of changes. So what we're looking at here is how our atmosphere has changed from when our Earth was this molten rock to what it is now, where life lives on it. And I'm going to have a look at that process. And the way to think about this really is that the Earth started off as a very, very volcanic planet. It's much, much calmer now. So that's where a lot of this early atmosphere comes from. And the graph I'm going to show you is this one. And it's quite a difficult graph to actually understand, but we'll give it a go. So this is 100% of the atmosphere. So at this point here, when the Earth started, right there, that line, that's the percentage of the atmosphere. So that's about about 5%. Nitrogen here, that sort of makes up, about 50%. You've got a little bit about 10% carbon dioxide, and then you've got about 25% water as well. Now, what the exam board does not expect you to know is all of these changes, right, to the right percentage. What they want you to know is the general trend. Now, the only one you do need to know is the current atmosphere, and that's, as far as the exam board is concerned, about 80% nitrogen and 20% oxygen. Is a little bit off that. It's about 78 nitrogen, 21 oxygen, but we tend to round it. Now, what you're expected to know is what happens to the concentration of each gas and why it happens. And so I'm going to talk you through each one as it goes on. So the first one here is methane and ammonia. Now, methane and ammonia are likely to have come from, again, those volcanic eruptions, but they are organic molecules. They're quite important in making life. These are actually the wrong way around on this graph. This is CH4 is the formula for methane, and NH3 is the formula for ammonia. But I did struggle to find a much better graph. So as a result, these are all used for biological life. So they start to drop. They also are quite flammable as well, or methane's flammable as well, so it does get rid of it. It's easy to get removed. Water comes along very early. It's a gas. However, as the planet starts to cool, it starts to condense. It forms rain. It then forms the oceans. So this is the reason you get a very quick drop in the concentration of water, is because it condenses and turns into water and turns into the oceans. Now, nitrogen tends to make up the majority of the atmosphere. The reason it makes up the majority of the atmosphere is because it doesn't actually do anything. So it's always been there. It just does nothing. It's like a buffer. It makes up a huge percentage of the atmosphere because it doesn't really react. There's only things like lightning, very specific bacteria, those sorts of things that can actually make nitrogen react. So the other two interesting ones are carbon dioxide and oxygen. And carbon dioxide is one that's quite often misconstrued because it starts off as quite a big proportion. However, there you go, that's about its highest point. However, it drops rapidly. Now, when asked why this is, most people go, oh, it's photosynthetic plants. Well, that can't be the case, because if carbon dioxide was going down, then oxygen would be going up at the same time. So there must be another reason. And the reason why carbon dioxide drops very early on is because the water is now oceans, and carbon dioxide is actually quite soluble. So the carbon dioxide dissolves into the oceans, which means that the concentration of carbon dioxide drops. Years later, carbon dioxide does start getting removed by life and photosynthetic life, so plants, and turned into oxygen, which is the cause of this rise in the level of oxygen. Oxygen was actually originally a poison to animals. However, we adapted and mitochondria developed to be able to use it for respiration. So we had this rise in oxygen. If you get asked why carbon dioxide levels decrease, you can get them answered for saying because of photosynthesis. If you get asked why levels of carbon dioxide decreased in the early atmosphere, you will lose the marks if you say that, because there was not photosynthetic plants. There were not plants. There were not anything that can photosynthesize early on. it was because it dissolved in the oceans. So, summarise. Use for organic materials, however, these are not ever examined. They don't come up. Nitrogen's inert, so it doesn't really do anything. It comes from volcanoes. Carbon dioxide comes from volcanoes. Water condensed, which meant that it formed the oceans. Carbon dioxide dissolved in those oceans, which meant it dropped. Oxygen's a product of photosynthesis, so it rises.